you tell me one thing. Is it looking spherical or elliptical? What is the shape of it? Spherical or elliptical? Elliptical. This is elliptical shape. Did you saw sun at the center? Is the sun at the center? No, the sun is not at the center. So every planet moves in an elliptical orbit. Which orbit? Elliptical orbit, with the sun being at one of the focus point. So whenever elliptical orbit is talked about, sun will be where beta? At one of the elliptical point. And sorry, focal point. Note down this one. Where will be the sun? The sun will be at the focal point. Where will be the sun? The sun will be at the focal point. Understood. So somebody will be asking you, then your answer will be the sun will be where beta? The sun will be exactly present at the any one of the focal point. Where it will be located? At the focal point. Got it? So this is about Kepler's law. Law of orbit. Every planet moves in an elliptical orbit. Which orbit? This is elliptical orbit, with the sun being at one of the focal points. So where is the sun? Is the sun is at the center? No. The sun is at any one of the focal point. So this is exactly one location and this is the other location. This is called as the location of focus. So either the sun will be here or the sun will be here. Understood? So this will be considered as what? Focal point. What it is considered as? Focal point. Now look here. This is one concept given. The second concept given by Kepler is very, very important. And he told that the line joining, see, you understand one thing. If somebody will be asking you, is all the, see, if Earth is revolving around the sun in circular orbit, then one thing must be there. What is that one thing is, ki seasons will be uniform. There will be only summer season or there will be only winter season. Why different type of seasons are coming? One time cold is coming, one time hot is coming, means the weathers are continuously changing. What is the specific reason behind change of weather? There must be some answer, na? What is the specific reason behind change of weather? So the answer is, yes, there is a change of weather. Yes, there is a continuous change of weather. So exactly why it is happening? Because the earth is not revolving around the sun in what you call circular orbit. It is exactly in elliptical orbit. Good evening, ma'am. I'm fine. So it is exactly what? Elliptical orbit. It is not circular. It is elliptical orbit. I hope you might have understood. It is not circular. It is what? Elliptical. Got it? So now we will understand the next part. So second part is the line joining the sun and the planets sweep out equal area in equal interval of time. What it is exactly sweeping out? Equal area in equal interval of time. Equal area in what? Equal interval of time. Equal area in equal interval of time. So let a planet move along from a position A to position B in time t. So definitely you see beta, planet is moving from one point to point A to point B. And what is the time taken beta? Understood? What is exactly the time taken? The time taken is t. And then it moves from position C to position D. And here see, if it is the sun is at more focus, so see what will be the season here? Understood? And what will be the season here? Understood. So just we are just concluding it. Now we will understand it. So but one thing is exactly given, when the earth will be near to the sun, when the earth will be near to the sun, at that particular moment, actually the velocity will slightly higher. The velocity will increase. But if it will be exactly going lesser, then the velocity will decrease. So that means it is exactly one of the most crucial factor to understand. Understood. So can we conclude this one? So now beta note down this one and let's check this one out. Let's check this one out. Let's understand this part. So if somebody will be asking you, let a planet move from position A to position B in time t and then it moves. So exactly the area swept will become equal. The area swapped, that means what? This area and this area remains the same. The area swapped in this situation and the area swapped in this situation is same. So now first, what was the first point? What happened? Ultimate crazy video. Okay, so here law of every planet move in an elliptical orbit with the sun being at one of the focal points. That's it. Second point, if somebody will ask, they will say that the area swiped by this and the area swiped by this in time t will be equal. In time t will be equal. Understood? The third point we are going to understand. Just you remember one thing. Just read that part, law of period. In the square of this part, first note down. I'll explain this one. What happened to you? Nice. Pada. I read. Just now I read. I hope you might have understood this one, beta. So this is one most important conclusion we can draw from here. So now beta, law of period. So law of period is what? The square of period of revolution of a planet around the sun is proportional to cube of semi-major axis of the elliptical orbit. What is semi-major axis, beta? This is exactly one formula you need to understand, but we are not going to go with that. Our main important Kepler's law is, the most important Kepler's law here, what we are going to remember is t square, time period of revolution, is directly proportional to cube of r, radius. Understood? You write down this one. This is the conclusion. Usually Kepler's they are not asking. Okay. Kepler's means only one thing we are understanding, that the time period of revolution is cube root of its rotation. Understood? So r will be there. So cube root of rotation, that part only is there. Can you go for the next one, please? Arunisha, are you there in the group? I hope till here understood, beta. Note down this one. So our second conclusion is law of period. The square of period of revolution of a planet around the sun is proportional to the cube of semi-major axis of its elliptical orbit. Got it? So now, beta, but in shortcut, what we are going to remember? In shortcut, we are going to remember this section. That is, see, that is this one. T square is directly proportional to R cube. T square is directly proportional to R cube. T square is directly proportional to R cube. This we remember. This we must remember. T square is directly proportional to R cube. Got it? No, it is for class 9th. You are in which class? I hope you might have understood this one. So now we are going for t square is directly proportional to r cube. Understood na beta? That is the Kepler's third law. Just roughly you remember that is considered as what? Kepler's third law. Got it? 11th. 11th today morning, no. I'm keeping some extra class for 11th. Tomorrow I'll be informing you, huh? Now we are going to understand, since different planets are at distance from the sun, different distance, therefore their time period are different. Pluto, which is the farthest, it is completing its revolution is how many? Wow. See, Nishan, understand this one very nicely. So Earth is taking how much days to complete? See, if somebody will be asking you this, this question is simple question that is the revolution, is the time period of revolution of every planet same? The answer is no, because of its distance from the sun. Got it? So how much it will be distant away, that much time it will take to revolve around one complete revolution, that much time it will take. Understood? So Pluto is very far. So since Pluto is very far, means it will take more time to complete one revolution. Understood? Earth is taking how much? 365 days and 6 hours, 8 hours or 6 hours. So here, if you will be talking about 8 hours, then 24 hours is getting completed. Correct now? So here, you need to understand that when Earth is taking this much for one complete revolution, our Pluto is taking how much? Check, 247 years. How many years? 247 years. So it will take 247 years. The period of revolution of Mercury around is closest to the sun is 81 days. But Mercury is exactly very near to the sun. So it is exactly completing in how many days? 81 days. How many days it is taking, beta? 81 days. So that's very important to remember. How many days it is taking? 81 days. Did you understood this part? Did you understood this part, because it is taking at least how much days? 81 days. That's most important to remember. Over. So now we will be going to the next part. Come on, go for the next section. Go for the next section. Center of mass and center of gravity. What does this mean? Until now, we have been mainly concerned with motion of single particles. When we have deal with extended bodies, means what? Better understand one thing. Here, if you will be reading about all these things, it is not going to work to that much. First, we are going to understand that center of mass and center of gravity. See, first we are going to understand center of mass is what. Can anybody tell me how I'm going to get the mass of a body? From the center or from the outer portion? Okay, so now here we are going to understand this part. See, all the contents are very heavy. This is for your notes only, but we will be doing this one. So we are going to understand. So mass of the body will be, mass of the body will be exactly fixed. It is not going to change. Whether you are in what you call moon, or you are in Earth or any other planet, the mass of the body remains the same. Understood? So now how we are going to justify the mass? But if somebody will be asking you this content, then what you are going to talk about? This one, center of mass and center of gravity. Center of gravity. So whenever we will be talking about the force, the distance, we will be always conclusive from the center point. Understood? So now let's check this one out. The motion of the body indicate that even if the body rotates, or there are several bodies that move relative to each other, there is one point that moves in the same path, that at a particular that a particle would, if subjected to the same net force. Understood? So this is called as the center of mass. What it is exactly considered as? Center of mass. So beta, you need to understand this. I am going to understand one thing with the help of this. So now I am also in your class. So if somebody will be talking about the center of mass, so what can be considered as the center of mass? So we have understood one thing, that the body is full of mass. The body is full of mass. Understand this. So this is exactly an object, circular shape object, and it is having what? Mass? Particles. It is having many particles. So we are going to consider one particle. Got it? So now the particle will be in that location from where the distance of other particles is exactly changing. Got it? So this will become the center point. So what it is called as? Center of mass. This is exactly considered as center of mass. This is considered as center of mass. Now चलो एक बार देख लेते हैं. Center of mass, इनको एक बार समझा देते हैं. कैसे समझेंगे? So look here, observation of the motion of the bodies indicate that even if a body rotate, or there are several bodies that move relative to each other, there is one point. There is what point? One point that moves in the same path, that a particle would be subjected to the same net force. Understood? So one particle will be exactly experiencing same net force from all the direction. The particle will be experiencing what? Same net force. Understood? So that will become the center of mass. What it will become? Center of mass. Quickly note down this one. This is a very important point. Observation. What is the observation, beta? The motion of the bodies indicate that if a body rotates or there are several bodies that move relative to each other, there is one point that move in the same path, that a particular would that a particle would subject to the same net force. Note down. And this point is called as center of mass. What this point is considered as, beta? Center of mass. The center of mass of a body or system of body is the point that moves as through all of the mass where concentrated there, and all external force were applied there. In most equilibrium problem, one of the forces acting on the body is its weight. So this is one thing we must understand. See, many times the people are having confusion related to this contents. Okay, so you should not be having confusion. So you understand one thing: if somebody will be talking about mass and if somebody will be talking about weight, mass and weight are not two same thing. Weight is what? It's a force. It's a type of force. What is what? Weight. Weight is a type of force. Weight is a type of force. So this point is called center of mass. The center of mass of a body or system of body is the point that moves all through, that is as through all of the mass were concentrated there, and all external force were applied there. All external forces are applied there. So just understand, one ball is there. In ball, one center point is there, and all the external force will be equilibrium to that point. Understood or not? So that will become the center of mass. What that will become? Center of mass. Did you got this point? Now, beta, one of the force acting on the one of the forces acting on the body is its weight. But actually, this is what I wanted to say. Weight is a type of what? Weight is a type of force. What is what? What is what? Good evening, Sankalp. What is what? Apart from that, just one gap I am giving. Then I will ask the question again. What is what? What is what? It's the unit of power. Yes, the power has a unit, and that is exactly what? What is that? Power of, what is power? SI unit of power is what? So I was just kidding you. Okay, now listen. But we can always calculate the torque force which rotate a body due to the body weight by assuming that the entire force of the gravity is concentrated at the point called at the center of gravity. So beta, here now two different things we are learning. First though, we were discussing about what? Center of mass, and then we were discussing about center of gravity. Center of mass and center of gravity. So if any object will be rotating, at the time of rotation, what it is exactly experiencing? Force it will experience. Understood? So just read this. But we always calculate the torque. Means what is the meaning of torque? Force which rotate a body is called as torque. What is torque? Force which rotate a body is called as torque. Okay. Now if the force which rotate the body is called as what, beta? Torque. Now due to the body weight, by assuming that the entire force of gravity is concentrated at the point called as the center of gravity. So definitely work, power, energy in one night. That chapter is coming. Numericals, kinetic energy, potential energy related questions and numericals will be coming 100%. So now look here, beta. So you need to understand. So geometrically, so we are understanding the gravity. So center point will be taking as the center of gravity. The center of any planet will be considered, in short, will be becoming the center of gravity. Okay. So it is due to this reason that while calculating the gravitational force between two bodies, we consider their center to the center distance. Got it? So distance between the center of gravity. So center of mass is there and center of gravity is there. So what are the two things? Center of mass and center of gravity. Okay. So we have understood about this. Good evening, beta. So center of mass and center of gravity. Two things we have understood. Now look at it, gravity and gravitation. Gravity and gravitation. So understand this one. The force of attraction between any two bodies in the universe having the mass of same order is called as gravitation. Got it? So it will be exactly having that continuous pull. So now you need to understand that that is called as force of gravitation. That is called as what? Force of gravitation. Okay, can I ask some questions from you? See, some questions I'm going to. Okay, Vijay. So please pay attention here. First, I need to understand some points with from you. See, if I will be exactly in a lift, okay, and if I am in a lift and I am ascending up, going up, will my mass be affected or weight be affected? Moon will not be falling on earth because force is equal to mass into acceleration. Okay, so here acceleration and mass, they are exactly involved, so inversely proportional to each other because of that, huh? That's the most important thing you must remember here. See, beta, understand one thing. That's what the apple is falling on earth. The earth is not going towards apple. Though force are exactly same there. Got it? So mass is equal to, can we do in a very simple way. Please understand that. See, objects are having equal forces. You need to understand that. Which your concept, I'm just explaining this one. So you please understand that force is equal to mass into acceleration. Got it? So you need to understand that the mass, if we will compare the mass of earth and acceleration generated and mass of apple and accelerated acceleration generation, we will be understanding that the mass of earth is exactly more, so the acceleration generated will be very very less. Got it? So it will be definitely not allowing the, what you call, allowing the earth to go towards the apple. Since the apple is having less mass, its acceleration will be more. So that's what is the concept is about. Okay, so definitely, but beta, instead we will have two hands like this. We can clap also, but the most important thing is there is some attractive force needed there, so you need to overcome. Many things are there. Okay, attractive pull will be there, but distance between them, so only I was discussing this point right now. Only we were just discussing about that point, like from where we can take the distance. The distance will always be taken from the center. From where we are taking the distance, beta? The distance is always taken from the center. So next class we are going to discuss about the remaining parts. Okay, bye everyone.